Everyone, my name is Kevin Zolkiewicz, and I'm a principal designer here at 8light. I've been working in the software industry for almost 2 decades now, and that designer title can actually be a bit deceptive, as I tend to get fairly involved with engineering efforts as well. In the past few years, in particular, my focus has been on user interface engineering and creating design systems. Today, I'm going to talk about design tokens, more specifically, some strategies for creating and deploying design tokens within an enterprise environment. If you don't work a lot in a front-end code base, you might not be familiar with design tokens. So what are design tokens? Really, they're just variables. They can be CSS variables, Sass variables, or JavaScript variables. They can also be used in native applications, including iOS or Android apps. But we call these particular variables design tokens because they represent key design and style choices in our applications. These include color, typography, spacing, and a lot more. There are a few big benefits that come with using design tokens. One of the biggest, particularly among designers, is that they help achieve visual consistency in our applications. Design tokens are often part of a larger design system, a whole set of guidelines and rules as to how an organization's applications should look and behave. By tokenizing key style decisions, we can help ensure conformance by using these tokens both as designers creating new interfaces and as developers building the interface. From a developer's perspective, design tokens give us better reusability, scalability, and maintainability. We can very easily do things like tweak a particular shade of blue, or even create a dark mode by swapping out the values of our token definitions. Creating design tokens doesn't necessarily need to be complex. You can just start creating some CSS variables in a file called tokens.css, and you're good to go. And this approach can work just fine for many smaller applications. But what happens when you're supporting a larger organization? Having all of your tokens in just one file can get difficult to manage fast. Some questions that might come up are, how do we keep all these tokens organized in a logical way? How do we create a consistent naming convention that maximizes flexibility? How do we manage tokens in a way so that we can support multiple formats? These are the areas that my talk is going to focus on. I recently completed a major update to the Spark design system, no relation to SparkConf, for cars.com. As part of this work, I led an overhaul of their design tokens, and these were all questions that I had to answer going into that process. So today we're going to cover token organization, how to manage what could turn out to be hundreds of individual tokens. Token naming, how can we ensure your tokens are all named in a consistent and logical manner? Creating tokens. Once we have a plan in place, how can we go about collaborating with both designers and engineers to plan out the tokens we'll need? And then managing and distributing tokens. We'll look at a tool that lets us define design tokens in JSON and then transform and output them in virtually any format. So first, let's talk about how we can organize our tokens. You'll want to tackle this problem first because it will ultimately inform how you name your tokens. I've looked at a lot of other public design systems for inspiration in this area, and I found this article by Lucas Opperman to be very informative. Lucas describes an organization system involving 3 tiers. The idea is that each tier would build upon the previous tier and offer an increasing level of abstraction. The 3 tiers are core, semantic, and component. Let's start with core. Core tokens are generally the only tokens that will store raw values. These tokens form the basis of an entire token architecture. So we may have values like hex codes, font family stacks, or font sizes. We'll ultimately name these tokens with only a small level of abstraction, say color blue 500 to reference a particular shade of blue. These are the only tokens where the name of our token will describe the value of what they return, rather than describing how the tokens are used. That distinction is important, particularly if in the future we want to develop a larger theming architecture. We wouldn't want to directly consume a token that references the color blue if someday we decided to offer a magenta theme. It's for that reason you'll typically consider most core tokens to be private tokens. The idea is very much similar to private methods or classes in our code base. These tokens are purely building blocks that we will use as a design system developers to create more abstract tokens that are intended for direct consumption. The next tier up is called semantic tokens. These are the tokens that developers are going to most frequently reference. For the most part, all of these tokens are going to equal a core token. The big difference is that these tokens will describe how a particular value is used in an application. So we might have tokens like color text link or color border focus. And both of these tokens may return the same core token. But if in the future we decide to change our focus border to be a different color than our link color, we can do that very easily. And if down the road we want to support a different theme, we can change the definition of these tokens in a systematic way that doesn't leave us with a bunch of specific color names hard-coded in our styles. The last tier of this organization system is component tokens. These are the most abstract of all the tiers. These tokens represent the values that would typically be consumed by prepackaged components, things like buttons, accordions, and tab UIs. The names of the tokens in this tier will get pretty specific, and their values will typically equal a token from the semantic tier. So we may have button color background primary, which returns color background accent. These component tier tokens are particularly valuable when you allow your components to be themed or reskinned. You're essentially developing a style API that allows consumers to change a component's appearance just by providing different token definitions. So that's our overall organization system: core tokens, semantic tokens, and component tokens. And you can see an example here of how each tier builds on the previous tier. These tiers can also inform how we structure tokens in our file system. We'll cover more about how we can store tokens a little later. So that's our token organization. But now we get into the really fun part, and that's token naming. This is where things can get really tricky and difficult to manage if you don't have a good plan in place. For example, is it background color button, or color background button, or button color background? As someone who likes to be organized and gets real bothered when there's a lack of conformity, this is an area where I always want to focus on getting things right. You can't really decide to iterate on your naming scheme down the road without either having two different naming formats or breaking all of your tokens. So like with the organization tier, my first step here is doing a lot of research and exploring other token libraries to learn about their approaches. Again, Lucas Opperman had some great advice, but I also came across an article by Nathan Curtis that looked at other token libraries and dissected their approaches. Nathan describes his approach using the term levels for each naming segment and offers a breakdown of potential levels and ways to group similar levels together. I prefer the term segments, so that's what I'll use in this presentation. All of these segments can seem like a lot, but keep in mind that most tokens are not going to make use of every possible segment. Most of your tokens are only going to use 3 or 4 of these segments in their names. Token naming schema in particular is an area where different setups are going to work better for different use cases. Determining how many and which segments are right for you can vary depending on the complexity of your application and any special design considerations. So this process will certainly involve some research for your specific use cases and applications. So I'm going to talk about 9 potential segments in this talk. They are namespace, component, part, category, concept, property, variant, state, and scale. Again, that sounds like a lot, but the vast majority of our tokens are going to pick and choose just a few of these. Nathan's article that I referenced earlier talks about some of other possibilities that could be worth exploring depending on your needs. But let's talk about these specific segments and how we can use them. The first one is easy, that's namespace. This is just a way for us to scope our tokens and declare them as part of a specific library. This is handy to avoid naming collisions if you're incorporating different token libraries or migrating from a prior token library. So for our examples, we use the name Spark, which happens to work for both the name of this conference and the design system I worked on at CARS. This is one of the only segments that will consistently use in each and every one of our tokens. The next 2 segments, component and part, are going to be used only for our component tier tokens. The component segment will reference the name of the component, such as button, card, or accordion. The part segment will defer to a distinct element within the component, such as a button's icon or an input's placeholder text. Most component tokens will incorporate both of these segments, but some simpler components might omit the part segment. The next group of segments, category, property, and concept, are the most central and important segments. Our semantic tier tokens will typically define all 3 of these. Category is a way to group the types of values that are returned. So you might have categories of color, font, spacing, shadow, and breakpoint. The property segment would further define either the value to be returned or how that value is expected to be used. For example, for color, properties might include background, text, or border. For font, properties might be family, weight, or size. Concept is a way to further define and group types of tokens. For font tokens, you might use concept to group individual tokens for heading and body text. You might also use concept to group colors for user interface elements that communicate feedback. Another possible use is to group colors associated with common social media services. The next set of segments are typically used as modifiers to offer alternative versions of our baseline tokens. These include variant, state, and scale. Let's look at some examples of variant. For a button component, you might use variant to distinguish primary, secondary, or tertiary button values. Going back to the feedback concept example, variants can represent different types of feedback, like success, warning, or error. State is generally used for various interactive states, like hover, focus, or selected. And finally, the very last segment, scale. Scale can be used in a number of ways. For example, spacing tokens can use scale to define the various level of different spacing values. You can also use scale to define different values for corresponding screen sizes. For example, if your heading font sizes increase depending on your screen size. So that's it, 9 different segments. Again, it might seem like a lot, but as I mentioned earlier, most of these tokens are just going to use a few of these. So let's take a look at some example token names for each of our tiers. I'll omit the namespace in these for simplicity. Some core tokens might include color violet 400, font family sharp sans, size radius 4, breakpoint medium. Semantic tier tokens, color background action hover, font weight heading, size radius input, shadow tooltip, and some component tokens, button color background primary hover, notification icon color fill success, rating star color fill active. Before we wrap up talking about naming, there are a couple of additional topics I want to cover. As I mentioned earlier, one is about the different ways to handle scale. But first, a way to identify core tokens as private tokens. When I talked about our different token tiers, I mentioned that most core tokens are not intended to be directly consumed by developers. Most of the time, there's going to be a semantic tier token that better describes the use case in a more abstract way. So to build on a long-standing convention in languages like JavaScript, I like to prepend most core tokens with an underscore symbol. For example, spark underscore color blue 500 and spark underscore font weight semi-bold. I like this convention for 2 reasons. One is to serve as a signal to the developer that this is a token you probably shouldn't be using. But when developing tokens, you also want to account for the reality that a use case could arise for which an appropriate semantic token doesn't exist. There are a couple scenarios a developer could take in that case. One would be using a different token that happens to return the right value, but that can end up with a border token being used to control a background color. That's not great. Another option would be to forget about tokens entirely and just use a raw value. That's better, but can still cause us problems in the future if you wanted to support different themes. So for these cases, I would actually encourage developers to just use a private token. The benefit to the underscore designation in this case is that you can routinely audit your styles to find cases where a private token was used. If you see a private token being used in similar use cases, it can help inform the creation of a new semantic token to better represent how a specific value is being used. The last consideration I want to cover while talking about naming is how to identify scale. I mentioned earlier the scale segment that many tokens are going to incorporate. There are a handful of different options for measuring scale. They typically fit into categories of ordinal or numeric scale. Let's talk first about ordinal scale. The most common type of ordinal scale is t-shirt sizing. This is the scale that traditionally I've reached for the most often. So you might have tokens like spacing small, spacing medium, spacing large, and spacing extra large. And this could be fine for tokens that only have a small number of scales. But t-shirt sizing has some drawbacks. For example, what if you want to add additional sizes in between existing values? spacing medium large, spacing larger. It can get messy really fast. Similarly, if we had to support a large number of scales, we can really start to stretch the limit of what this system can accommodate. This scale can also be a little difficult to provide an indication of what value a token will return. Is medium 16 pixels or 24 pixels? Until you memorize them all, you end up having to reference the documentation fairly often. So this type of scale naming can often be handy, but isn't always the best. Numerical-based scaling can offer a lot more flexibility. An area where I've traditionally used numerical scale is with naming color shades. So you might have as many as 10 different shades of a given color, particularly for a theme's neutral color. You can use an ordered scale of 100 to 900 to identify shades from lightest to darkest. The benefit of this is that if you want to add a shade between 500 and 600, you can squeeze that in and call it 550. If at some point you have a shade lighter than 100, you can call that 50. But another scaling system that I learned about not too long ago is from the US web design system, which, yes, the US government does have its own design system. Their spacing tokens use values like spacing 0.5, spacing 1, and spacing 3. I was a little perplexed by this system at first, but once I learned about it, I started to really appreciate it. This is a proportional scale. It starts with identifying a base scale, let's say 8 pixels, and then using multipliers as the scale name. So 8 pixels would be 1, 16 pixels would be 2, 20 pixels would be 2.5, and so on. This system has several benefits. It gives us a lot of flexibility in the number of values we can track and makes it easy to insert additional in-between values in the future. It also helps to communicate the resulting value that the token represents. So all you need to know is the base scale, and then if you see spacing 4, you can do the math and know that will return 32 pixels. You don't have to constantly reference the documentation to remember what large represents. So what scale should you use? Well, it depends. I typically end up going with a mix of different scales depending on the type and number of values. Core tier color tokens are most often going to use the ordered scale I described earlier. Core tier font size and spacing tokens will generally work best with a proportional scale. But for many instances in semantic tier tokens where you're only tracking a small handful of values, t-shirt sizes might be sufficient. So all that covers how we organize tokens and name them. As I said in the beginning, it's ideal to have all of these schemas defined up front before you start creating your individual tokens. But once you're at the point where you're ready to start making tokens, how do you make sure you're following your conventions? And what's the best way for both designers and developers to collaborate together to identify your tokens? That's what we'll cover in this next section. So when it comes to token creation and collaboration, it's best to use a platform that's accessible to both designers and developers. Starting with code could offer a structured format, but would be more of a barrier for designers to contribute. Tools like Figma are also a possibility, but tend to lack structure and an easy way to ultimately transform the work into code. So a method I've ended up having great success with is Google Sheets. This offers a number of benefits. For one, it's great for real-time collaboration by both designers and developers. Everyone is generally familiar with Google products, so there's a minimal learning curve. But a spreadsheet is also actually a great way to enforce and keep track of the various naming segments of a token. You can create columns to represent each segment, and then use an additional column to record the value. With a tier-based organization system, I recommend creating individual sheets for each tier. You can then further organize the spreadsheets by creating separate tabs for categories in core and semantic tiers, and tabs for each component in the component tier. The other benefit to Google Sheets is that if a particular category or component isn't making use of a certain naming segment, you can easily hide those columns to simplify things and improve readability. I recommend adding a few additional columns to each spreadsheet depending on the tier. For core tokens, a preview column can be very beneficial for categories like color. You can also use a preview column for animation timing tokens to visualize the Bezier curve. For semantic and component tokens, where their value will typically equal another token, I like to have a raw value column that contains the value ultimately returned by the token. This makes things a lot easier to quickly see the value return without having to constantly cross-reference multiple sheets. Each spreadsheet also benefits from a notes column, where you can include things like more detail about where a particular token is intended to be used. So with the tools in place, you're ready to start creating tokens. This can be a little daunting at first if you're not sure where to start. I recommend beginning by identifying core tokens. If you're coming from a previous token library or already have an established design system, you should already have a rough idea of what you'll need here. But you also want to examine your application code bases to look for usage patterns and identify which token values you might need. For example, for typography tokens, it can be helpful to create an audit document that lists every font size and line height value used throughout your applications. You'll also want to review any current or future design mockups to identify core token needs there as well. Once you have your core tokens roughed out, I recommend starting with just the names of your component tier tokens. These tokens will generally be set to return a semantic token, so getting a better picture of all the tokens needed for your components will be a huge help in determining semantic tokens. Once you've identified the names of your component tokens, you can then use that information, combined with both additional audits of your code base and by reviewing in-progress designs for future features, to create a list of semantic tokens. There's a lot of additional thought process that can go into naming your semantic tokens. I don't have enough time to dive deeper into that today, but the general goal is to develop names that are generic enough while also providing guidance on how the token is intended to be used. For example, I like to use the term action for tokens that will frequently be used with both links and buttons. Finally, with your semantic tokens identified, you're now able to go back and assign values to your component tokens. As you move throughout the different tiers, you'll often find yourself going back amongst the different tiers to rethink or modify tokens that were already created. This is completely expected, so it's important to remember that nothing is really set in stone until you have all of your token names and values in place for all of the tiers. Finally, I want to touch briefly on the process of actually packaging and distributing design tokens. There are a number of ways to handle distribution of tokens. If you've only got a handful of tokens, it's not too difficult to just manually maintain some CSS or Sass variables. But when you're dealing with potentially hundreds of tokens, you're going to want some better tooling. This is particularly important if you want to be able to output tokens to different formats. So the tool I recommend for this job is an open source project called Style Dictionary. Style Dictionary allows you to define all of your tokens using JSON documents. Once you've got those created, you can output to a large variety of formats out of the box, or even define your own special format if you'd like. You can also use it to perform transforms on your token values. For example, automatically convert pixel values to relative values like rem, or switch between different color formats. It's really powerful in what it can do, and I've only scratched the surface here. Once you've got your style dictionary files and configurations set to go, you can include it as part of a build system to output your token files and distribute them. For larger organizations supporting multiple apps, I recommend versioning and distributing your tokens by packaging them as an NPM package or something similar. So that's all great for letting developers use tokens. But what about designers? It would be great if the JSON files we create for Style Dictionary could automatically be fed into tools like Figma. I did some research into this last year and did find a few third-party plugins that offer a way to load and synchronize tokens so they're available as Figma variables. But there have traditionally been some limitations in the types of variables that Figma supports, and overall, none of the plugins I looked at really won me over. But there is some promising news here. Just last month, Figma introduced an entirely revamped variable feature, which also offers a REST API. I haven't had a chance to play around with this yet, but I'm hoping we'll start to see some exciting new options here, maybe even a way for Style Dictionary to integrate with Figma. So that's about all the time I have today. Let's review some of the key takeaways for creating design tokens. First, create an organization plan. Figure out how you're going to divide up your tokens, whether it's through tiers like core, semantic, and component, or some other way. Develop a consistent naming plan. This includes determining what types of scale you want to use for different token variances. You want to ensure your token names are predictable, so there's less ambiguity about how a token is intended to be used. And don't be afraid of long token names. Consider Google Sheets for planning your tokens, especially if you're collaborating with a team. Use a tool like Style Dictionary to manage tokens and avoid having to manually create and manage additional formats. And remember that there's no one right way to create design tokens. Depending on your needs and applications, you might pick and choose from some of the ideas that I mentioned today. It can be perfectly acceptable to end up with a system that's simpler or even more complex than what I showed. The important thing is having a design token system in place to ensure that both designers and developers can get their job done in a way that's consistent, scalable, and maintainable. Thank you so much.